Hari Om. Hello everyone, I am Sri Jyoti. Welcome back to my channel. Today's video is of class 12 mathematics chapter 7 integrals part 15 definite integral. So make sure that you have watched all the videos from part 1 to part 14. So in the previous sections we have discussed about the indefinite integrals and we learned some methods to finding them, right? So here in this section we will study definite integrals. See, in the introduction I have already mentioned that this integration is nothing but it is used to find the area of the region under the curve. Okay, look at this graph. Y is equal to f of x, a continuous function on interval AB, closed interval AB. Okay, so how to find the area of this region? We make many rectangles and adding up their areas, right? So here let's divide this closed interval AB into n subintervals of length h. That is, there are n subintervals of length h. Okay, suppose this length is h. Okay, so here if this point is A, then this point is nothing but A plus h, right? And this point is nothing but A plus h, that is A plus 2h, right? Okay, etc. See here, if this point is A, this height is nothing but f of A, right? This point is A plus h, so this height is f of A plus h. Okay, so here we can write the average value of the function, that is f of A plus f of A plus h, okay, value of the function plus f of A plus 2h plus etc. plus f of A plus n minus 1 into h, because there are n subintervals, okay, and starting from 0, right, A plus 0h, f of A means A plus 0h. So starting from 0, so ending n minus 1, because there are n subintervals, divided by n. Okay, that is average value of the function is nothing but sum of the functions divided by number of subintervals, right? So f of A plus h plus etc. plus f of A plus n minus 1 into h. Okay, so we know that, see, area is nothing but length into width. Area of the rectangle is length into width, right? Okay, so here, see, that is length is here height. Okay, so what is the average height of this one? You see, here we know that when n is increasing, actually we draw many rectangles, right? So when n is increasing, the length of the subintervals getting smaller. Okay, that is when n getting larger, we this length of the subintervals get smaller, right? So here we can write the average height is equal to, see, f of A plus h plus etc. plus f of A plus n minus 1 into h. See, when n getting larger, what is the value of this one? Okay, that is, so how can we write? Limit n tends to infinity. We know that when n getting larger, the subintervals, length of the subintervals getting smaller and smaller. Okay, so how to find the average height? Average height is limit n tends to infinity f of A plus h plus etc. plus f of A plus n minus 1 into h divided by n. Okay, so here it is the average height. Okay, now we can find how to find the area. Okay, area of this region, that is nothing but we know that area of the rectangle is length into width, okay, or height into width. Okay, so here what is the length? See, this width is nothing but b minus a, right? This width is b minus a. So we can write area is equal to b minus a into height, right? That is length of this rectangle. Okay, so average height, that is limit n tends to infinity f of A plus f of A plus h plus etc. plus f of A plus n minus 1 into h divided by n. Okay, so here it is the area of this region. So in integration we write it as integral a to b f of x dx. Okay, integral a to b f of x dx. Okay, such integration is called a definite integral. There are lower limit and upper limit. This a is called the lower limit of the integration and b is called the upper limit of the integration, and f of x is the integrand. Okay. Let's go through an example. Evaluate integral 0 to 1 x dx as the limit of a sum. See, here we can evaluate it directly, but here it is given we have to evaluate it as this limit of a sum. That is, here we have to find the sum of all the intervals from 0 to 1 and the function is x. Okay. So first of all, let's write here integral a to b. We have already found the sum of the limit of the sum of the function f of x, right? So here let's compare this integral to given integral, okay, with a given integral. That is, here a is equal to 0, b is equal to 1 and f of x is equal to x. Okay, then next h. See, what is h? See, we have divided the given interval AB into n subintervals, right, of length h, right? We have divided this closed interval AB into n subintervals of length h. Therefore, what is h? H is nothing but b minus a divided by n. Okay. So, here h is equal to b minus a divided by n, that is equal to 1 minus 0, that is 1 by n. That implies nh is equal to 1. Okay. Now here we know that how to find the integral a to b f of x dx. Now what is our formula? That is limit n tends to infinity 1 by n into b minus a into limit, that is f of a plus h plus etc plus f of a plus n minus 1 into h, right? So here we have to find all the values of the function, that is f of 0. Okay, here a is 0, therefore f of 0 plus h, f of 0 plus 2h, etc. Okay, so let's find f of a. What is f of a? F of 0, right? F of 0 is, see, given function is f of x is equal to x, therefore f of 0 is 0. Next, f of a plus h, that is 0 plus h, that is equal to 0 plus h is f of h, that is equal to h. Okay. Now next is f of a plus 2h, that is 0 plus 2h, that is equal to f of 2h, that is equal to 2h. Okay, etc. What is the last term? F of a plus n minus 1 into h. Here a is 0, therefore f of 0 plus n minus 1 into h, that is equal to f of n minus 1 into h, that is equal to f of x is equal to x, therefore f of n minus 1 into h is n minus 1 into h. Okay, now let's find the value of this integral. We know that what is the formula? That is, this given integral is equal to limit, here we will give h tends to 0, because here we know that when the number of subintervals getting larger, that is n getting larger, the length of the, here see, suppose there are many, we draw many rectangles, right? So here when n getting larger, the length of the subintervals become smaller and smaller, right? So here we can write, see, h is nothing but length of the subintervals, okay? This length, okay? Therefore, when n getting larger, this h becomes smaller and smaller. So here we can write the limit h tends to 0. Okay, when n tends to infinity, h tends to 0. Okay, that is when n getting larger, h getting smaller. Okay, so here limit h tends to 0, then length, see, actually we wrote b minus a divided by n, right? So here b minus a divided by n is nothing but h. Okay, so h into then f of a, that it is our formula. Okay, to find the value of the integral, right? So integral a to b f of x dx is equal to, we wrote already, that is limit n tends to infinity b minus a divided by n into, that is average value of the function. So here f of 0 plus f of 0 plus 2h plus etc plus f of 0 plus n minus 1 into h. Okay, that is limit h tends to 0, h into, what is, we have to substitute, okay, these values. What is f of 0? 0 plus, it is f of 0 plus h, then f of 0 plus 2h. Okay, so 0 plus h plus f of 0 plus 2h is 2h plus etc. plus n minus 1 into h. Okay, that is equal to, see here, limit h tends to 0, h into, see, in all the terms h is common, right? So we can take this h outside, so it will become h square. Okay, so h square into this 0 is 0. Okay, so here 1 plus 2 plus 3 plus etc. plus n minus 1, right? We have taken h outside. Okay, then say what is the sum of this? Here we know that 1 plus 2 plus 3 plus etc. plus n is equal to n into n plus 1 divided by 2, right? So here 1 plus 2 plus 3 plus etc. up to n minus 1, right? So when it is n into n plus 1 by 2. So 1 plus 2 plus 3 plus etc. plus n minus 1 is, here in place of n minus 1. Okay, so n minus 1 into, next n plus 1, here n plus 1, so here n minus 1 plus 1, that is n, okay, divided by 2. So its sum is limit h tends to 0, h square into, this sum is n into n minus 1 divided by 2. Okay, so here we can write it as, see, remember we have the value of n into h. Okay, so according to that we have to simplify this one. See, here we can write it as limit h tends to 0. See, let's write nh, and 1h we can write this h, take this h inside of the bracket. Okay, so here we have taken this h here into, then nh minus h, okay, divided by 2. That is, see, after simplifying, expanding, you will get the same thing. Okay, so here we have taken this h n here, okay, and taken one h here inside of the bracket, that is nh minus h. Okay, that is equal to, so that we can substitute the value of nh, right? Okay, limit h tends to 0, here nh is equal to 1, and here 1 minus h divided by 2. Okay, now substitute h is equal to 0. Okay, that is, when substitute h is equal to 0, you will get 1 into 1 minus 0 divided by 2, that is 1 into 1 by 2, that is 1 by 2. So 1 by 2 is the answer. Okay, so integral 0 to 1 x dx is equal to 1 by 2. Now let's go through exercise 7.8. First question we have already done. Second question, integral, evaluate integral 0 to 5 x plus 1 dx. Here given function is x plus 1 and a is equal to 0, b is equal to 5. Okay, let's write, given integral is I is equal to integral 0 to 5 x plus 1 dx. Okay, here a is equal to 0, b is equal to 5, f of x is equal to x plus 1. Okay, now what is h? H is equal to b minus a divided by n, that is 5 minus 0 divided by n, that is equal to 5. That implies nh is equal to 5. Okay, now let's find each value of the function, that is f of a, that is f of 0 is equal to, here 1, right? F of x is equal to x plus 1, f of 0 is equal to, substitute x is equal to 0, so 0 plus 1 is 1, right? Next, f of 0 plus h, that is equal to f of h, that is equal to h plus 1. Okay, then f of 0 plus 2h, that is equal to f of 2h, that is equal to 2h plus 1, that is enough. Next we will find last term, that is nth term. Okay, f of 0 plus n minus 1 into h is equal to f of n minus 1 into h, that is equal to n minus 1 into h plus 1. Okay, now let's find the value of this integral, that is I is equal to limit h tends to 0, h into f of 0 plus f of 0 plus h plus x, f of 0 plus 2h plus etc. plus f of 0 plus n minus 1 into h. Okay. That is equal to, now let's substitute these values. Limit h tends to 0, h into, here what is f of 0? 1, okay, 1 plus here h plus 1, right, h plus 1, f of 0 plus 2h is 2h plus 1, 2h plus 1 plus etc. plus last term is n minus 1 into h, n minus 1 into h plus 1, okay. See here, how many ones are here? See how many times? See, starting from, that is, there are, we know that there are n terms, n subintervals, okay. So here there are n ones, okay. So here we can write limit h tends to 0. Let's write all the ones together, okay. H into, here 1 plus etc. plus 1, that is n times, okay, because there are n terms, okay. So starting from, see, f of 0 is 1, so next f of 0 plus h is h plus 1, there is 1, okay. So there are n ones are there, okay. Okay, then plus here after writing all the ones together, see, h plus 2h plus 3h plus etc. plus n minus 1 into h, right. So all the terms h is common, right. So we can take outside h into 1 plus 2 plus 3 plus etc. plus n minus 1, right. That is equal to, here limit h tends to 0, h into, here it is nothing but 1 plus etc. plus 1, n times is nothing but that their sum is n, right. Okay, so it is n plus h into, this one is nothing but n into n minus 1 divided by 2, okay. This sum is n into n minus 1 divided by 2, okay. Now here we can write, because here we have value of nh, so according to that we will simplify this one. Limit h tends to 0, nh plus here also nh into this h, okay. We have to multiply this h, okay, these both terms by h. So here it will be nh into nh minus h divided by 2, okay. Now let's substitute the value of nh, that is equal to limit h tends to 0, here 5 plus 5 into, here 5, okay, 5 minus h divided by 2. Now let's substitute limit value, apply the limit, that means substitute h is equal to 0. So here it will be, it is 0, so 5 minus 0, so 5 into 5, 25, okay, okay, we have applied limit. So after applying the limit, 5 plus 5 into 5, 25, 25 divided by 2, that is 10 plus 25, 35 divided by 2 is the value of the given integral, okay. Next one is evaluate integral 2 to 3 x square dx. Here given function is x square, a is equal to 2, b is equal to 3, f of x is equal to x square, okay. So let's find, okay, what is h? H is equal to b minus a divided by n. B is 3 minus 2 divided by n, that is equal to 1 by n, that implies nh is equal to 1. Okay, now let's find f of a. What is f of a? F of 2, right? F of 2 is equal to, f of x is equal to x square, so f of 2 is equal to 2 square, that is 4, okay. Next f of 2 plus, that is a plus h, so 2 plus h is equal to, here 2 plus h whole square, right, that is equal to 4, expand it, so 4 plus 4h plus h square, right. Next we will find f of a plus 2h, that is f of 2 plus 2h, that is equal to, here 2 plus 2h whole square. Okay, because f of x is equal to x square. So f of 2 plus 2h is equal to 2 plus 2h whole square. Expand it, that is 4 plus here 4 into 2, that is 8h plus 4h square, right? Okay, a plus b whole square, a square plus b square plus 2 into ab. Then, so now let's find last term, that is f of 2 plus n minus 1 into h, that is equal to 2 plus n minus 1 into h whole square, that is equal to a plus b whole square. So a square, 2 square 4 plus 2 into a into b, that is 2 into 2 4, 4 into this one, right? So 4 into n minus 1 into h plus b square, that is n minus 1 whole square h square. Okay, it is the last term. Okay, now let's find the value of this integral, that is I is equal to, okay, limit h tends to 0 h into f of 2 plus f of 2 plus h plus f of 2 plus 2h plus etc. plus f of 2 plus n minus 1 into h. That is equal to, here let's substitute these values. Limit h tends to 0 h into, what is f of 2? F of 2 is 4, right? 4 plus, next f of 2 plus h, 4 plus, okay, 4 plus 4h plus h square. Next f of 2 plus h, f of 2 plus h is 4 plus 8h plus 4h square plus etc. plus, here this one is 4 plus 4 into n minus 1 into h plus n minus 1 whole square h square. Okay. Now here see, in all the terms 4 is there, right? See 4 plus here 4, that is n times 4 are there, right? So here we can write all the 4 together. So limit h tends to 0, 4 plus etc. plus 4, that is n times. Okay, because see in all the terms 4 is there, right? So here we can write it together, that is n times, so that we can write 4 into n, right? Okay, plus after that see 4h 8h, see here 4h 8h, then 4 into n minus 1 into h. So in all these terms h is common, so we can take it out, h into 4 plus 8 plus, okay, etc. plus, so here we can take 4n outside, right? 4h outside, okay, 4h into, okay, 4h is common, okay, in all the terms 4h is common, so we can take 4h outside. So here it is 1 plus 2, next will be 3, okay, etc. plus, here we have taken 4h outside, so remaining n minus 1, okay, plus after that see here h square plus 4h square plus here etc. plus n minus 1 whole square into h square. See in these terms h square is common, okay, so let's take it out. H square into 1 square, okay, here 1 square, here plus 4, see 4 can be written as 2 square, okay, plus etc. plus here n minus 1 whole square, okay. Then that is equal to, here limit h tends to 0, it is nothing but 4n, because there are 4n, n times 4, okay. So n times 4 are there. So here we can write limit h tends to 0, 4n plus, h is there, okay, don't forget to write h into 4n plus, here 4h into, now let's write the value of this sum. Say 1 plus 2 plus 3 plus etc. plus n minus 1 is nothing but n into n minus 1 divided by 2, right? Plus here h square into, see what is the sum of this? n into n minus 1 into 2n minus 1 divided by 6. Okay, n into n minus 1 into 2n minus 1 divided by 6. So that is equal to, now let's simplify this one. We have the value of nh is equal to 1. Okay, so here limit h tends to 0. So let's multiply all these terms by h. Okay, so here it will be 4nh plus here 4h square. Okay, n into n minus 1 by 2 plus here h cube n into n minus 1 into 2n minus 1 divided by 6. So it is equal to limit h tends to 0. Here 4 into 1, that is 4. Okay, because we have got nh is equal to 1. Okay, plus here we can write it as 4nh and take 1h here inside of the bracket. Okay, that is nh minus h. Okay, plus here h cube. So here first I will write nh and 1h for this back bracket and another h for this bracket. Okay, that is here we can write nh minus 1. Next 2nh minus not 1h. Okay, we have to multiply this. So 2nh minus h divided by 6. That is equal to limit h tends to 0, 4 plus here nh is 1. Okay, so 4 into nh is 1, 1 minus h divided by 2 is here, right? Yes, divided by 2 plus here 1 into 1 minus h into nh is 1, so 2 minus h divided by 6. Now let's apply the limit. That means we have to substitute h is equal to 0. Okay, so after applying the limit, 4 plus here h is 0, so 4 into 1, 4 by 2 is 2 plus here h is 0. Okay, so 1 minus 1, 1 and 2 minus 0 is 2, so 1 into 2, 2 divided by 6, that is 1 by 3. That is equal to here 6 plus 1 by 3, that is 18 plus 1, 19 divided by 3. It is the value of the given integral. Evaluate integral 1 to 4 x square minus x dx. Here also we will write a is equal to 1, b is equal to 4, f of x is equal to x square minus x and h is equal to b minus a divided by n, that is equal to 4 minus 1 divided by n, that is 3 by n, that implies nh is equal to 3. Then we will find f of a, that is f of 1. F of 1 is 1 square minus 1. Okay, that is 0. Okay, next we will find f of a plus h, that is f of 1 plus h, that is equal to 1 plus h whole square minus 1 plus h. Okay, that is equal to here 1 plus, let's expand it, 1 plus h whole square is 1 plus 2h plus h square, here minus 1 minus h. So here it will be 1 cancelled, then 2h minus h is h, so h plus h square. Okay, next we will find f of 1 plus 2h, f of a plus 2h, right? So 1 plus 2h, that is equal to 1 plus 2h whole square, 1 plus 2h whole square minus 1 plus 2h. Okay, minus 1 plus 2h. 1 plus 2h whole square is 1 plus 4h, okay, a plus b whole square plus 4h square, 4h square, here minus 1 minus 2h, that is equal to, here 1 cancelled, 4h minus 2h is 2h, 2h plus 4h square. Okay. Now let's find last term, that is f of 1 plus n minus 1 into h, that is equal to here 1 plus n minus 1 into h whole square minus 1 plus n minus 1 into h. Okay. That is equal to here 1 square 1 plus 2 into n minus 1 into h, okay, plus n minus 1 whole square h square. Next term, that is minus 1 minus n minus 1 into h. That is equal to, here also 1 is cancelled. Then 2 into n minus 1 into h minus n minus 1 into h, that will be n minus 1 into h, right? N minus 1 into h plus n minus 1 whole square h square. Okay. Now let's find the integral. Our formula is limit h tends to 0 h into f of, what is a? 1, right? F of 1 plus f of 1 plus h plus f of 1 plus 2h plus etc. plus f of 1 plus n minus 1 into h. Okay. That is equal to, now let's substitute the value of these functions. Limit h tends to 0 h into, here f of 1 is 0, okay, plus f of 1 plus h plus h square, plus f of 1 plus 2h plus 2h plus 4h square, plus here etc. Last term is n minus 1 into h plus n minus 1 whole square h square. Okay. Then limit h tends to 0 h into, here see h plus 2h plus next 3h, then see etc. n minus 1h. So in these terms h is common, we can take it out. So h into, here it will be 1 plus 2, next plus 3 plus etc. n minus 1. Okay. 1 plus 2 plus etc. plus n minus 1 plus here next term, that is h square, next 4h square. See, after that etc. n minus 1 whole square h square. In those terms here h square is common, so we can take h square outside. So remaining here it will be 1 plus 4. 4 can be written as 2 square. Okay, 1 can be written as 1 square plus etc. plus here n minus 1 whole square. Okay. Then limit h tends to 0 h into, here h into, this sum is nothing but n into n minus 1 divided by 2 plus here h square into, this sum is nothing but n into n minus 1 into 2n minus 1 divided by 6. These all things we have already studied in our 10th standard, right? The sum of square of these numbers, okay? That is, here limit h tends to 0. Now let's multiply these terms by h. So it will be here h square. So we will write it as, see, nh, okay, into this h, nh minus h by 2 plus here also nh and this h also, okay. So it will be h cube. So 1h I will write nh and take 1h for this bracket and another h for this bracket, okay. So here nh minus h into 2nh minus h divided by 6. Now let's substitute value of nh. After that apply the limit. So here limit h tends to 0. nh is nothing but 1, right? Sorry, 3. 3 into 3 minus h divided by 2 plus here 3 into 3 minus h into 2 into 3, 6 minus h divided by 6. Okay. That is, now let's apply the limit. So it will be apply the limit h, that is substitute h is equal to 0. So that is equal to, I is equal to 3 into 3 minus h, that is 3 minus 0, that is 3, okay, 3 by 2, plus 3 into 3 minus 0, okay, 3 minus 0 into 6 minus 0 divided by 6, that is equal to, here 9 by 2 plus 3 into 6, 18, okay, 18, 3 ones are, 3 twos are, so 18 divided by 2, that is 9 divided by 2 plus 9, that is equal to 18 plus 9, that is 27 divided by 2. Integral minus 1 to 1 e raised to x dx. A is equal to minus 1, b is equal to 1, f of x is equal to e raised to x. Very important question. So here evaluate integral minus 1 to 1 e raised to x dx as limit of a sum. Okay. So here, so first of all, okay, let's find h is equal to b minus a divided by n, that is 1 minus 1, that is 1 plus 1 divided by n, that is equal to 2 by n, that implies nh is equal to 2. Okay. Now let's find f of a, that is f of minus 1, that is equal to e raised to minus 1. F of x is equal to e raised to x, therefore f of minus 1 is equal to e raised to minus 1. Next we will find f of a plus h, that is minus 1 plus h, that is equal to e raised to minus 1 plus h. Okay. Next f of a plus 2h, that is minus 1 plus 2h, that is equal to e raised to minus 1 plus 2h. Okay. Etc. f of minus 1 plus n minus 1 into h, that is equal to e raised to minus 1 plus n minus 1 into h. Okay. Now let's substitute. Let's find the value of the integral, that is I is equal to limit h tends to 0 h into f of minus 1 plus f of minus 1 plus h plus f of minus 1 plus 2h plus etc. plus f of minus 1 plus n minus 1 into h. That is equal to limit h tends to 0 h into, here f of minus 1 is e raised to minus 1 plus, next is e raised to minus 1 plus h plus e raised to minus 1 plus 2h, okay, plus etc. e raised to plus minus e raised to minus 1 plus n minus 1 into h. Okay. See, this can be written as limit h tends to 0 h into, here see, we know that e raised to minus 1 plus h, that is e raised to minus 1 into e raised to h, right? That is, so here we can write e raised to minus 1 plus e raised to minus 1 into e raised to h. Okay. E raised to minus 1 plus h can be written as e raised to minus 1 into e raised to h plus e raised to minus 1 into e raised to 2h plus etc. plus here e raised to minus 1 into e raised to n minus 1 into h. E raised to minus 1 into e raised to n minus 1 into h. Okay. That is equal to limit h tends to 0 h into, here see, in all the terms e raised to minus 1 is common. So let's take it out. E raised to minus 1 into, here 1 plus here e raised to h plus here e raised to 2h plus etc. plus e raised to n minus 1 into h. Okay. That is equal to, here limit h tends to 0 h into e raised, see, we can take e raised to minus 1 outside. E raised to minus 1 is a constant, so we can take it out from the limit. So we can take this e raised to minus 1 outside, limit h tends to 0, okay, h into, here see, here we have 1 plus e raised e square, that is e raised to 1 plus e raised to 2 plus etc. plus e raised to n minus 1 is e raised to n minus 1 divided by e minus 1, okay. But here it is 1 plus e raised to h plus e raised to h whole square plus etc. plus e raised to h whole raised to n minus 1. That sum is e raised to h whole raised to n minus 1 divided by e raised to h minus 1. Okay. If h is equal to 1, then it will be e raised to n minus 1 divided by e minus 1. Okay. Then after that, so e raised to minus 1 limit h tends to 0. See, here we can write this h as, that is denominator of denominator. We know that if a value that is denominator of denominator come to numerator, right? So that we can apply the limit. Okay. That is, here we can write e raised to h. It is nothing but e raised to nh, right? E raised to nh minus 1 divided by, here e raised to, okay, here e raised to h, okay. So here e raised to h minus 1 divided by h, okay. I have written this h here. That is same value, okay. So here this denominator of denominator come to numerator, right? So that we can apply the limit. We have a limit h tends to 0, e raised to h minus 1 divided by h is 1, okay. Therefore, here now we will substitute the value of nh. So e raised to minus 1 into limit h tends to 0. Here it is e raised to nh is equal to 2. So e square minus 1 divided by, here we can apply the limit, okay, e raised to h minus 1 divided by h, okay. Now apply, see, we have limit, we know that limit h tends to 0 or limit x tends to 0, e raised to x minus 1 divided by x is equal to 1, okay. Therefore, limit h tends to 0, e raised to h minus 1 divided by h is 1, okay. Therefore, it will be e raised to minus 1 into e square minus 1, okay. What is e raised to minus 1? That is 1 by e, okay. 1 by e into e square minus 1, that is equal to e, that is, so multiply 1 by e into e square, that is e minus 1 by e, right? E minus 1 by e. Integral 0 to 4 x plus e raised to 2x dx. Here a is equal to 0, b is equal to 4, f of x is equal to x plus e raised to 2x, and h is equal to b minus a divided by n, that is 4 divided by n, that implies nh is equal to 4. Okay. Now let's find f of a, that is f of 0. F of 0 is equal to 0 plus e raised to 0, that is 1. Okay. E raised to 0 is 1. Next, f of a plus h, that is 0 plus h, that is equal to f of h, that is equal to h plus e raised to 2h. Okay. Then f of a plus 2h, that is 0 plus 2h, that is equal to f of 2h, that is equal to 2h plus e raised to 2 into 2h, that is e raised to 4h, etc. F of 0 plus n minus 1 into h, that is equal to f of n minus 1 into h, that is equal to, here n minus 1 into h plus e raised to 2 into n minus 1 into h, right? Okay. Now here we will substitute these values here. We will find the value of the given integral. Okay, that is I is equal to, okay, limit h tends to 0. It is our formula, okay. H tends to 0, h into, here f of 0 plus f of 0 plus h plus f of 0 plus 2h plus etc. plus f of 0 plus n minus 1 into h. Substitute these values. Limit h tends to 0, h into f of 0 is 1 plus f of 0 plus h is, see, h plus e raised to 2h plus f of 0 plus 2h is 2h plus e raised to 4h plus etc. plus last term, that is n minus 1 into h plus e raised to 2 into n minus 1 into h. Okay. Then that is equal to, see here, we will write, see, h plus 2h plus 3h plus etc. plus n minus 1 into h. Let's write it together. Okay. So it will be limit h tends to 0, h into, here, h plus 2h plus h plus 2h plus etc. plus n minus 1 into h plus next term see 1 plus e raised to 2h, okay, 1 plus e raised to 2h plus here next e raised to 4h plus etc. plus here last term e raised to 2 into n minus 1 into h. Okay, then limit h tends to 0, h into, see here h is common, so we can take it out, h into, so it will be 1 plus 2 plus etc. plus n minus 1, right? Okay, plus here it will be, see 1 plus e raised to 2h plus e raised to 2 into 2h, that is 2h whole square, okay. See here we can write it as, I will write 1 plus e raised to 2h, okay, plus e raised to 2h whole square, okay, e raised to 2h whole square, okay, plus etc. plus e raised to 2h whole raised to n minus 1, okay. So here let's write the sum, limit h tends to 0, h into, here h into n minus 1 divided by 2 plus here this will become, this sum is nothing but e raised to 2h whole raised to n, okay, minus 1 divided by e raised to 2h minus 1, okay. In previous, that is last problem, here it was e raised to h, okay, e raised to h whole raised to n minus 1 divided by e raised to h minus 1. Here it is 2h, okay. So e raised to 2h whole raised to n minus 1 divided by e raised to 2h minus 1, okay. Then that is equal to, here limit h tends to 0, we will multiply these terms by h. So here we will write this nh, okay, and this h here nh minus 1 divided by 2 plus, and we have to multiply this h here also. So here it will be e raised to 2nh minus 1 divided by, and here we will write this h here, okay, that is denominator of denominator, e raised to 2h minus 1 divided by h, okay. So here we will write 2h, okay, because we have to apply the limit, okay. Therefore here we have divided, that is multiplied 2, therefore we have to divide 2, okay. That is equal to, here limit h tends to 0, let's apply the limit, okay, directly let's apply the limit. So it will be nh is equal to, value, substitute the value of nh, that is 4 into 4 minus, it is not 1 h, okay. So 4 minus 0, that is 4 divided by 2 plus here it will be 1, okay, after applying the limit it will be 1, and here it is 2 into 4, that is e raised to 8 minus 1 divided by this 2, okay, that is equal to, here 16 divided by 2 plus e raised to 8 minus 1 divided by 2, that is 16 minus 1 is 15, so 15 plus e raised to 8 divided by 2.